Through the concept builders that are assigned to Mr. Force integrated science classes. Just take a look at them, give an example so you can visually see what to do. So remember, when you sign in to Physics Classroom, you've got an account, make sure you sign in. If you don't remember your password or it wasn't saved in your Chromebook, you should be able to go reset that. It'll send you a recovery email to your school email. At any rate, once you do that, we're going to go to the Match That Free Body diagram. Oh, when you click on that, it'll have a bunch of things like your classes and things in the middle of the page. You're going to want to select on courses and tasks. The tasks would be Newton's Laws Concept Builder, and then the first one you would choose is Match That Free Body diagram. So when you do that, I've asked you to do the master level and the wizard level. This for 6 points only, this for 8 points only. Do them both, you get 10 points in standard F2. So as a physical situation is described below, tap on the free body diagrams until you find a diagram that's consistent with the physical situation. A bundle of hay is attached to a truck by a rope, is moved across the dirt to the left at a constant speed. So if it's constant speed, those forces are balanced. Tension would, I think, be acting to the left. I think this is the right one, but I want to check the other ones. That would not be correct because it's not a constant speed. I have a greater tension force than I have a frictional force. Same thing, unbalanced forces, so not a constant speed. This one, that's weird. I guess you could call that an applied force if you want, but still it's unbalanced. Those are balanced, but the fact that it's being pulled doesn't make sense to me. So I'm going to have something like that. And I'm going to check it out, and I'm going to check the answer. And that is okay. So you would continue on with these. Remember, if you need help, get help here, how to think about the situation type. Force types are listed here as well. So that's something we've talked about and I've given you notes on as well. So the next one that I want to do is go to the net force ranking task. It's also with net acceleration. So I'm going to launch that concept builder. I may have to go through two examples here. So in this one, I'm going to ask you to do the apprentice level for 6 points, the master level for 8 points. If you do both of those, you get 10. You do not need to do the wizard level. If you want to, I guess you could get bonus with that. So it says rank the objects according to acceleration. Use 1 for most negative and 4 for most positive. So left is negative and right is positive. If you're unsure about that, it says that in the help menu. So talks about how to get the net force and how to get the acceleration. So this is Newton's second law. So I think the ones with net force are easier to figure out than the ones with acceleration. So when I go back here to this one, this is actually going to rank the objects according to acceleration. So and you'll tap each of these, 1, 2, 3, 4, 1 being the most negative, 4 being the most positive. So when I look at this one and this one have forces going to the left, so those would be negative. So I'm going to look at those first. These two forces going to the left add up to negative 10 newtons. Divided by 2 kilograms gives me negative 5 meters per second squared. 6 newtons divided by 0.5 kilograms gives me negative 12 meter per second squared. So that is the most negative. So that's a 1 and that's going to be a 2. For these ones then, when I look, I'm going to have 8 newtons here, 2 newtons here. They're acting in opposite directions, so I subtract them. So that's 6 newtons of net force to the right, which is positive. 6 newtons divided by 0.5 kilograms gives me 12 meters per second squared to the right. Here I've got more net force to the right because both these forces are pointing to the right. So I've got 10 newtons in net force. But the acceleration is 10 newtons in net force divided by 10 kilograms. That's only 1 meter per second squared acceleration to the right. So this would have the most positive, so that's number 4. Most positive acceleration. This would have the second most positive acceleration, so that's 3. So most negative is 1, next most negative is 2, most positive is the highest number, not as positive as the middle number there, which is 3. So I think I did that right. Yep. So you do those same sorts of things. Now in this case, this one's talking about net force, so it's easier. Here, most negative, I've got 8 newtons of going to the negative. Here I've got 8 newtons negative but 4 positive, so the net force is 4 newtons and negative only. So this one's the most negative, this one's not as negative, and then this one is the most positive, so that would be 4. It's 10 newtons of positive. This is 8 minus 4, so only 4 newtons of positive, so that's third. So you're ranking them from most negative with 1 to most positive for 4. And that should be correct. So yep, so that's the idea of how to do that. And hopefully that's a good tutorial.